We've covered the tools. Now we move to judgment. In this module, you'll learn to recognize recurring context problems, such as retrieval, custom data, and complex analysis, and match each one to the right solution: LLMs, RAG, fine-tuning, classical ML, or hybrids. At this point, the building blocks are on the table: traditional ML, LLMs, RAG, and fine-tuning. Module 4 shifts the focus from how these techniques work to when each one solves a real context problem. A context problem pattern is a repeatable shape of need. The key question is not, should we use RAG, fine-tuning, or a database? It is, what must be available for the system to succeed? That might be fresh information, trusted data, strict formatting, personalized behavior, or the right structure at the right moment. Before choosing an architecture, diagnose the context scenario. Ask 4 questions. Where does the needed knowledge live? Inside the model, in documents, in a database, or in user state? How fast does it change? Rarely, daily, or in real time? What must the answer look like? Flexible prose or a strict schema? And what happens if it is wrong? These answers narrow the solution space before you debate LLMs, RAG, fine-tuning, or classical ML. Once you understand the information pattern, match it to a solution family. If knowledge is mostly static and inspectable, RAG is often the first candidate. If facts change quickly, retrieval at runtime matters more than memorizing them in the model. If output must follow strict fields, formats, or business rules, add structure through schema enforcement, classical ML, fine-tuning, or a hybrid. The goal is not to choose the fanciest method. It is to pick the failure mode you can control. Consider a static FAQ or document Q&A bot. The goal is not creativity. It is grounded accuracy. Think of an HR policy assistant or product documentation bot. The source material changes occasionally, but users expect official answers. So the system retrieves approved passages, answers from those passages, and includes citations so people can verify the response instead of trusting a guess. In this pattern, the main question is where the answer comes from. A plain LLM is quick, but it relies on what it already learned, so it may be outdated or invent details. Fine-tuning can shape tone, terminology, and behavior, but it is a poor way to store lots of changing facts. RAG is usually the default. Retrieve relevant passages, answer from that evidence, and use prompts for consistency. A typical RAG system has 2 paths. First, an offline indexing job pulls approved content, splits it into useful chunks, creates embeddings, and stores them in a vector database. Because the documents change slowly, this can run on a schedule. Then, at question time, the retriever finds the most relevant chunks, adds them to the prompt, and the model answers from that evidence, ideally with citations and guardrails against unsupported claims. Even with a fixed document set, RAG can fail quietly. Bad chunking may separate a rule from its exception. Retrieval may miss the right page because the user used different wording, and the model may confidently stretch beyond the evidence. Production systems need guardrails, require citations, allow I don't know, re-rank retrieved passages, and verify the final answer against sources. The goal is not just to answer, but to prove the answer is grounded. When knowledge changes fast, freshness becomes the main challenge. Product details, prices, inventory, policies, and incident updates may change every day or even every minute. Fine-tuning the model each time would be slow and risky. RAG avoids that by checking the latest approved source at answer time, like consulting the current manual instead of relearning the whole job. In fast-changing environments, retraining the model for every update is slow, expensive, and hard to audit. RAG gives you a cleaner separation. The model stays stable while documents, databases, indexes, and connectors are refreshed around it. That means newer answers, easier rollback, and a visible source of truth that teams can inspect and correct. Retrieval can also combine semantic search with filters like date, region, version, or role, so freshness and control improve together. For this pattern, RAG needs to behave like a production data pipeline. Start with authoritative systems, detect what changed, ingest it, and update the index incrementally. Metadata becomes essential: version, timestamp, region, customer tier, and product line. At query time, retrieval uses those tags to select the right chunks, not just similar chunks. Finally, monitor freshness, source usage, stale document rates, and support rollback when bad content gets published. Structured output tasks introduce a different kind of risk. Correctness means more than giving the right answer. The model must place the right value in the right field every time. RAG can supply facts, but it will not guarantee valid JSON, allowed enum values, or complete required fields. For production workflows, pair the model with schemas, validation, constrained decoding, or fine-tuning when consistency matters. These workflows are rarely solved by one technique alone. Start with prompting and a clear schema when the format is simple. If the answer needs facts, add retrieval so generation is grounded. If the output drives automation, validate it, then repair or retry failures. When the same pattern repeats at scale, fine-tuning can make behavior more consistent. And for stable labels or narrow extraction, classical machine learning may be the simplest, most reliable component. You now have a practical pattern library for context decisions. Stable, approved knowledge often points to RAG. Fast-changing knowledge usually does too, because freshness matters. Structured outputs need stronger controls: prompting, validation, fine-tuning, classical ML, or hybrids. Next, we'll compare these choices with a trade-off matrix.